Hello everyone, my name is Arun Kumar Chimakurti. In this presentation, I will be exploring the concept of enterprise data lakes and how Apache Hadoop serves as the backbone of this architecture. We will focus on technical architecture, core Hadoop components, and walk through a real-world example using Uber. Data lakes are a hot topic in enterprise analytics and a foundational aspect of modern data engineering, and Hadoop continues to play a vital role in building and scaling them. A data lake is a centralized repository that allows enterprises to store all the structured, semi-structured, and unstructured data at scale. The key characteristics are scalability, cost efficiency, and flexibility. Unlike data warehouses, which use schema on write, data lakes use schema on read, meaning the data structure is applied only when it's read or processed. This enables rapid data ingestion and diverse analytics. Enterprises use data lakes to support real-time analytics, machine learning, and large-scale data processing. Why Apache Hadoop for data lakes? Hadoop is widely adopted as the foundation for data lakes because of its distributed architecture and robust ecosystem. It offers the Hadoop Distributed File System or HDFS, which enables scalable and fault-tolerant storage of petabytes and data across commodity hardware. Hadoop supports batch processing through MapReduce and resource management via AND. Its ecosystem includes tools like Hive, uh, Spark, Kafka, and Presto, making it highly adaptable to various analytics and ingestion needs. Most importantly, Hadoop is open source, which brings down infrastructure costs while still enabling enterprise-grade deployments. Apache Hadoop ecosystem components. Let's now walk through the major components of the Hadoop ecosystem and how they support a data lake. HDFS stores the actual data and manages the computational resources. MapReduce processes large-scale batch jobs. Spark enables faster in-memory processing. Hive and Presto act as SQL query engines over large databases. Kafka and Flume handle data ingestion both in batch and real-time formats. Scoop brings in real data, relational data, sorry. Ranger and Atlas and security governance and metadata tracking. Together, these tools form the backbone of a modern enterprise data lake. The diagram flows from top to bottom, showing how data moves through our system. Let's look at how Uber uses a Hadoop-based data lake. Uber ingests real-time location trip and customer data using Apache Kafka. This data is stored in HDFS and Apache Hudi, which supports upsearch and ACID capabilities. Apache Spark processes this data in real time to predict demand, calculate search pricing, and optimize driver dispatch. Hive and Presto allow internal teams to perform SQL queries on massive datasets for business insights. This architecture supports their operational dashboards, fraud detection, and ML pipelines. By building a flexible data lake, Uber is able to support both real-time and historical analytics at scale. Benefits of Hadoop-based data lakes. There are several clear benefits. First, Hadoop enables a unified platform for handling diverse data types, from click streams to structured logs to videos. Second, it supports both real-time and batch processing. Third, it extremely cost-effective due to open source software and commodity hardware support. Governance tools like Ranger ensure compliance and secure access. Metadata tools like Atlas improve data discoverability. Finally, the architecture is highly modular, which means you can swap components based on specific needs. For example, you can use Trino instead of Presto or integrate MLflow for machine learning workflows. Future outlook. The future of Hadoop based data lakes lies in integration with next gen tools and cloud infrastructure. Projects like Apache Iceberg and Delta Lake bring ACID transaction, schema evaluation, and time travel to data lakes, bridging the gap between lakes and warehouses. Hadoop can now work with cloud native object storage such as AWS S3 and Azure Data Lake Storage. Apache NiFi and Airflow improve orchestration and data pipeline management. Lakehouse architectures are also gaining traction, combining the flexibility of data lakes with the performance of warehouses. Hadoop's core components are evolving to stay relevant in this hybrid ecosystem. In summary, Apache Hadoop remains a cornerstone for enterprise scale data lakes. It provides scalable, secure, and cost effective infrastructure for handling all types of enterprise data. Its ecosystem supports ingestion, processing, querying, governance, and analytics. As demonstrated with Uber, organizations can achieve near real time analytics and robust machine learning using Hadoop based architecture. With ongoing innovations, Hadoop continues to support modern data strategies, whether on premise or in the cloud. Thank you for your time.